Okay. Of course, last time we were talking about functions and how if you have them returning a value, although they always return something, whether you tell them to or not, but if you have them return a value that you can use, you can easily just kind of compose these functions and call functions, and then they return the value, which automatically gets getting passed as a parameter to another function call. You can do this all you want. And we also talked a little bit about scope and how sometimes the variables only exist in a limited area, like within the function if you declare it within the function. A little bit about optional parameters. We got through this at the very, very end of yesterday. You know, we set the value of A to be 9.807 almost always. And then if and when you want to assign a different value to A, you do it. But otherwise, just leave it alone. It'll automatically use that value. We also talked about imports, but I'll say a little bit more about them right now. I'm going to show you an example. Remember before I did this? And then if I wanted, I don't know. Give it a second. There we go. That's the value, I guess. See how I had to put math dot sign, right? Because we're saying from math, use the sign function. You can do it a different way, though. I'm going to restart the runtime. We can do something like this. From math, import, and we can write specific functions that we want to include. So maybe I don't really want all the functions. Really, maybe I only need like 2. So I'll save some time and specify them. Maybe I want sine and tan. There. Or a lot of times we can do something like this. What this says, from math, import, and the star means everything. Just take everything, copy, paste it, pretend it's in the same script. But if you do it this way, you don't need to include math dot in front of it. You might think, oh, well, this is fantastic. It's going to save me some time. Well, I actually, if you want to do it this way, go ahead. It's fine. There's nothing wrong with it. But I personally recommend not doing it. Because if someone looks at this code, let's say we go down here, you have no idea we imported math. If you look at this code and I see, oh, I'm calling the sign function, do you have any idea where that sign function is coming from? You don't. I mean, you might know because you know it's in math, but nothing about the way it's written tells you it's from the math group of functions. Where if we do it this way, then we have to say anyone who looks at this goes, oh yeah, okay, clearly they're calling the function from math. And this is fantastic, especially because what if you have 2 functions with the same name? Coming from 2 different places, or maybe you even define one. I'll show you an example. Let me get rid of all this. You can also do this to something if you want to short form it. I'll show you what I mean in one moment. Great. So from 2 different locations, I called the sign function. And although here they worked they look like they did the exact same thing. There are some differences in the back end that we don't need to go into. But the point is, when I say math.sign, you know which sign it's calling. When I say numpy.sign, you know it's calling the sign from numpy. I'm curious what will happen if we do this. it ran sign, but do you have any idea which sign it ran? You don't know. That could be really problematic. Let's do a quick test here on something. I don't know how well this one will work. Well, I guess it works just fine so far, but there are times that you will come across functions, even between math and NumPy, where they have the same name, but they will act a little different. And if you don't know where they're coming from, you might be in big trouble if you think you're calling that one, but really you're calling that one. So I strongly encourage you to not do it this way. I strongly encourage you to do it this way. Because now there's no ambiguity. You know exactly where these things are coming from. And what I meant up here is, if you're really lazy and you don't like to type NumPy, computer scientists are really lazy, a lot of people will do this. Then whenever you want to call it, you can just use, you just use the short form of it. That could be handy when importing large things like so now, if I ever wanted to call this, if I didn't do as PLT, I'd have to go, okay. Oop, it's not matplotlib, it's matplotlib. Like I'd have to type that. I'm too lazy. So I did the as PLT, so that really means I do this. Ah, so much nicer. Look at that. Anyways, yeah, NumPy. And comments. A lot of you already came across this, but comments are handy if maybe you've got a line of code that you don't want to delete, but you don't want running this time you hit run. Well, you can quickly go and comment that line out. And to do that in Python, it's just like the number sign. Now when I hit run, that line of code doesn't run. It stays there, so me as the human can read it, but it doesn't run. So that's handy. Another handy thing is, now in this particular scenario, it's not going to be overly helpful because it's pretty obvious what I'm doing. But maybe I want to write a little comment to myself or anyone who might be looking at my code. There. So now anyone who comes along and sees like, oh, why are they doing like print math sign and then NumPy sign? Well, they look at that comment and it tells them, oh, they were just comparing the two. Okay, cool. That's it. So this comment can be used to comment out code. It could be used to annotate your code so it becomes a little easier to understand, whether for yourself or anybody else who might be reading it. So that's really handy. And I suppose you don't need the space, but I think it's a common convention that if it's like stuff you're writing to yourself, add the space. There's another kind of comment you can do if you want to do a block comment. Block comments are handy if you want to have comments on multiple lines and you're too lazy to write the number sign every time. So what you can do is 3 of these, close it with 3 of those, and they could be the double quotes as well, but you have to do like 3 of them. And then you do like, blah, 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 blah. You can have as many lines as you want between this and that. These also become handy if you've got a block of code. So like if I want to comment all of this out, it's not that bad. I mean, okay. Oh, there, you know? Then if I want to uncomment or uncomment it out, I just go delete that. But, you know, I could do this. There, done. It's kind of handy. There is a convention I'm going to require you to use. You may have noticed it if you looked at assignment 1. A lot of programming languages have a lot of conventions. Some have fewer that everyone follows, and some programming languages have many conventions, which really fragments the users of the language. But one of the nice conventions here with Python is we have what we call function headers. A description about what a function does. But the way we do it is we'll say, okay, 3 open quotes inside the definition bit. We'll have the 3 closed quotes at the bottom. We have an explanation there. It says, set up a collection of cities, world, for a simulator. Oh, I guess this isn't from assignment 1, this is from assignment 2, actually. Pardon me. Each city is a 3-element list, and our world will be a list of cities. Param names a list with the names of the cities in the world, and returns a list of cities. If I had 4 different parameters there, I would describe each of them. So this way, anyone who comes along and looks at your code and they see this function, maybe it's this big, long, complex function, they should be able to read the function header and know exactly what it does and how to use it. So that's what you're describing in the function header. Oh, okay, well this function sets up the cities. Okay, great. All I have to do is get a list of names of cities, then it gives me back a list of cities. That's it. Make use of function headers. If you don't, you can lose marks in assignments. Any last questions about functions before we move on? Okay. So we're going to talk a little bit about conditionals, but before we can do that, we have to talk a little bit about logic. Very simple logic. This is stuff that you're probably actually already pretty familiar with because you use a lot of these ideas in your everyday life with the language you use. But we're going to talk about these things a little bit more formally. You've probably never even thought of these things to the level of detail we're going to talk about today. And you absolutely probably have not thought about these things as much as you will next year if you're taking computer science. But anyways, let's take a quick second. Load up your Colab and let's try real quick. And using only the stuff we've learned so far in class, write a function that will divide, or I guess a program, it doesn't have to be a function. Write a program that will divide a number in half only if that number is a multiple of 2. Give you a couple minutes to figure this one out. Pretty quiet, so you're working really hard, right? Did anyone get it yet? No? All right, I'll give you a minute. Or does anyone have any questions?
Is this possible?
What do you have back there?
I was wondering if it's possible with only the stuff that we already know.
Well, why are you asking that question?
Because I feel like we need this data.
All right, yeah. I played a trick on you. You can't do it. You can't do it with the stuff we've learned so far. Because, one, although this one's pretty easy actually, we can find this one out pretty soon, is how to check if a number is a multiple of 2. But you have no way of asking Python to check that question for you. You can't say, okay, Python, tell me if this is a multiple of 2. Because if you could ask that question, you could say, okay, Python, if this is a multiple of 2, divide it by 2. Otherwise, do nothing. So we need something called if statements, conditionals. But before that, we got to talk a little bit about logic. So sometimes some statements are true or false. Okay? Now, let me take a step back. If I say 1 plus 1 is 2. So I asked you a question. I threw a statement out there and you gave me the answer back. Okay? Now, don't think numbers. Think true or false. Okay? There's only 2 options. It's either true or false. So I'm gonna ask you another question. Is James wearing shoes?
Yes.
Let's try that again. Is James wearing shoes?
Yes.
Oh God, no. What? Say that again louder. Is James wearing shoes? There you go. Remember, we got to think in terms of true or false. What is this yes nonsense? Is James wearing a shirt? Is James wearing a hat? Is James wearing a watch? So you can see there are some questions that get evaluated to either true or false. Some questions get evaluated to numbers, like 1 plus 1 is 2. 2 plus 8 is 10. But some questions can be evaluated to true or false. Now, let me ask you this. Based on, I haven't even taught you this yet, but based on your familiarity with the English language, I'm going to ask you a question. Is James wearing shoes and a shirt? Is James wearing shoes and a hat? Why is it false? Because I'm not wearing the hat. Notice that when the question is and, when and is there, both statements that were involved in that question I was asking must be true in order for you to say true. Because here, think about it this way. When I asked you, and you were doing this whether you realized it or not, when I asked you, is James wearing shoes and a hat? You have a couple of things going on. The first question you ask is James wearing shoes? That's a question. And what does that get evaluated to? Who said yes? Who said it? You looked at him. Was it you? Well, okay. You should have said false. Okay, when I say, okay, let me get back on track. If I say, is James wearing shoes and a hat? You have to ask, is James wearing shoes? The answer to that is, then you also have to answer the question, is James wearing a hat? The answer to that is, so when you put a statement that is true, and you have a statement that's false, and you ask that and question, the answer is false. Both of the statements that you were evaluating must get evaluated to. We must do all that logic number crunching in the back. They must both be true in order for the and to be true. Let me ask you this. Is James wearing a hat and a watch? False. Neither of those statements were true, so it's false. So, and is something you're already familiar with. Let me ask you this. Is James not wearing shoes? Is James not wearing a hat? Notice how, as soon as we put that not modifier there, it just kind of flips the question. We can even go like this. If I ask, is James not wearing shoes? You ask the question, okay, is James wearing shoes? You say true. And then what's not true? False. It checks out, right? Is James wearing a hat? False. What's not false? True. Is James wearing shoes or a hat?
True.
True. Because I am wearing shoes. Who cares if I'm wearing the hat? Is James wearing a hat or a watch? Is James wearing shoes or a shirt?
True.
True. This is very simple intro logic. Now, you are already familiar with the mathematical operator plus and minus and multiplication and division, right? If I say 2 plus 2 is, you know that means take those two numbers, put them together, and give me that back. Give me the result back. That's what that operator does, right? And is an operator. It's an operator in the same sense that addition is. And I'm not being silly. And is like an operator. But it doesn't work with numbers. 1 plus 1, that plus, it's got to work with numbers. And it gives you a number back. And it works with these logical statements. And it gives you back like a true or false. Anyone know what we call true or falses in programming? All right, well, what?
Absolutes.
No.
Booleans.
Booleans, but more on that in a moment. Actually, I guess not really. They're called Booleans. It's a whole new type. Boolean. We know integers, we know floats, we know strings. We saw the type before too, which was weird. But we have a new one called Boolean. And let's test it out. Bool for Boolean. Warning. Quotations true is a very different thing than just true. Also, mind the fact that it's an uppercase T, not a lowercase t. The second one's a string, obviously, because it's got the quotes. The other one is a Boolean, and Booleans can only have two values, true or false. Integers can have like a bajillion values, right? It could be 1, it could be 2, it could be -7, and whatever. But Booleans, they're either true or false. That's it. And they help us with logic. So, and is an operator that takes two Booleans and gives us a Boolean back. So, real quickly here, I guess I'll turn on this light. We're going to create something called a truth table. It's one of the activities, but we're going to do it together because it might take a little too long if we try to do it by ourselves. Let's say we have condition A and condition B. Okay? If this could be the question that gets, this could be, A could be, is James wearing shoes? It's something that gets crunched down into a true or false statement. Okay? So what I want to do is take every combination of true-false combinations and see how or reacts and how and reacts and how not reacts, although not's pretty easy. And what I'm going to do is do a very verbose thing that you are already very well aware of by using English and going around your lives. Which you demonstrated when I was asking those questions. So, condition A, is James wearing shoes? That could be a true or false statement, right? So we've got true. And is James wearing a hat? Well, let's start with a statement that's true. Is James also wearing socks? Okay, that's true. But I could ask something that is true and then this is false, right? So maybe I ask you the question, am I wearing shoes and a hat? Could be an or as well, but the questions that I'm talking about are what's important. So this could be, is James wearing a hat? I don't know. Doesn't matter, that's the same one, they're just examples. Is James wearing a shirt? True. Is James wearing flip-flops? No. Is James wearing glasses? So I've created every possible combination of the answer to two questions that could be true or false. True, 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 false, false, true, false, false. There's no other combination of these four things, right? Four things. Well, I guess the two things, really. Right? Is there any questions about what I mean by that? There's no other combination of true or false if I've got two of them. Right? So, let's start with a simple one. What if I ask not A? So we ignore B right now. What's not true? Everybody. Yeah, exactly. So if we apply not to something that's true, we get false. I mean, true again. What's not false? True, yeah. Great. Now let's ask the question A and B. So if I have a statement that's true and a statement that's true, what does and give me? Everybody. The lack of enthusiasm concerns me. Am I just annoying you or is it unclear? If something is true and the other question's true and you and them, it's true. Is James wearing shoes and a shirt? True. Is James wearing shoes and a hat? Yeah. I can similarly ask, is James wearing a hat and shoes? The order doesn't really matter, I guess. Is James wearing flip-flops and glasses? The important thing here, though, to remember, because a lot of people forget this, that the questions I'm asking get evaluated to true or false before we can do like the and. Okay? So is James wearing shoes? True. Is James wearing a hat? False. True and false, that's false. It might seem like I'm getting like overly pedantic with, and like maybe overly technical, but that's kind of the point here. Let's try or. A or B. True or true? What do we think? True. Is James wearing shoes or a hat? Oh wait, or shoes or a shirt? True. Is James wearing, true or false? Is James wearing shoes or a hat? True. Is James wearing glasses or socks? True. And then, is James 10 feet tall or wearing shoes? Both are false. I'm not 10 feet tall. Great. So it looks like for and to give me back true, both statements must be true. But for or, all that matters is one is true. In fact, if I ask you the question, is James wearing shoes or, does it even matter what the next question is? Think about that for a second. Is James wearing shoes or, you don't care, do you? Because you know that as long as one of the two conditions is true, or gives you back what? Now, that cannot be said for and. Is James wearing shoes and? Well, you don't know. You don't know what the result's going to be. But what if I said, is James wearing a hat and? You immediately know, no matter what the next condition is, the result's false. Kind of cool, right? You can answer the question with incomplete information, I suppose. Now, what if I say not A or B? What do you think that's going to be? Take a second and think about it. What do we think? Yell. I'll give you a hint. If whatever A is gets evaluated to or pardon me, if whatever A is true, and you not it, what do you get? Well, A or B, well, it's true. What happens if we not this?
False.
False. What about this one? What? False.
True.
What if I do this? We can get really crazy now. If B and not A or B. Notice that I can make these as complex as I want as long as I'm using the right types here. In the same sense, I can say like, what's 1 plus 2? And you say 3. And I go, well, what's 1 plus 2 plus 7? Well, you could be like, well, okay, well, it was kind of the answer to 1 plus 2. And then I just add the 7 to the answer. That, like, I can keep adding to these all I want. So, B and not A or B. If you're like, oh man, that's hard. You're looking for the silver bullet, break it down in steps. The good news is we've actually got all the steps. We know what not A or B is. Right? So, what's the answer to this one? What's the answer to this one? So by the way, I just want to make very clear, what we're comparing right now is this column and this column, right? This is the B. And we're ending it with not A or B. So what's this one? And what's this one? So it's never possible to have B and not A or B, I guess. Let's think of a statement. Is James wearing a hat and not wearing shoes or a hat? I guess it kind of makes sense that would, not make any sense. Because am I wearing a hat and not wearing a hat? Well, I don't know. Did we do that right? False. Where did I make a mistake? All right.
First one.
Pardon?
First one should be true.
This one?
Yeah.
Why?
Because A or B is true, and then B is true.
Okay, okay, right now.
Oh, wait, never mind.
Oh, okay. So what are you saying?
I'm saying nothing.
You're saying nothing, all right. Everything looks to check out. True and false. I mean, that's true and false. Anyways, the point that we're focusing on right now is the not, the and, and the or. And then we can combine the nots, ands, and ors however I want with whatever statements. Where the statements are like A and B. Okay. So this is the truth table, that's the activity. So we just saw some operators that, so AND is an operator that takes two Booleans and gives me back a Boolean, right? Plus is an operator that takes two numbers and gives me back another number. I guess plus also is defined for strings, so we could say plus is also taking two strings and giving me back a string, I guess. But so plus takes two numbers, give me a number. And takes two Booleans and gives me a Boolean. But what if I ask you the question, is 6 greater than 4? What's the answer to that question? Is 6 greater than 14? So, greater than is another operator. But weirdly, it takes two numbers and gives me a Boolean. So, it's kind of like changing the types there. But do you see how it's still like a question? Like it's a statement that I want a true or false answer to. Is 16 greater than or equal to 1? Come on, a little bit, come on. Of course it's true. So these are operators that can compare numbers, but it gives me a Boolean back. And if you ever want to check if two values are equivalent, we use equals equals. We can't use regular old equals because regular old equals in Python is the assignment thing, right? If I say a equals 7, well, that means a takes on the value 7, right? So if we want to do a comparison, we need two equals. So let's do something here. So is 66 equal to 77? Is that a true or false statement? Of course it's false. Is it equal to 66? Yeah, 66 is equal to 66. You might be thinking like, well, you're just comparing two literals. Yes. But of course, imagine I had some function, some really important function that returns, and we save the value of this thing to be like 77. Right? Well, there we go. Because maybe this is a function that does some calculation. Now we can check if it's equal to it. I can say, is 4 greater than 8? Well, that's false. Is 4 less than 8? Everybody yell it. Now, here's a weird question. Is 4 less than 4? It's false, right? Because 4 is not less than 4. But admittedly, that's kind of like a funny edge case, right? If you're like, well, hold on, I don't know. It's kind of weird. Well, by definition, 4 is not less than 4. But it is less than or equal to 4. Oh. Similarly, it's greater than or equal to 4. So these are all operators that compare numbers and gives me back a Boolean. So we've seen operators that take two numbers, give me back a number. Two strings, give me back a string. Two Booleans, give me back a Boolean. And now two numbers and gives me back a Boolean. So think about this. I could say, is 4 less than 5 and 77 greater than 88? What do we think? What's the answer to this question? It's false. Well, is 4 less than 5? Who just said yep? Come on. Is 4 less than 5? True. Is 77 greater than 88? So I have a statement that's true and I'm ending it with a statement that's false. What do I get? False. Or not 55 equals 55 and 6 minus 45 is greater than or is less than 0, or 55 minus 44 equals 11. And for fun, let's not all of that. Well, I guess that's false. I wasn't going to think about it. But I just put this expression in, and it gets evaluated in a similar way that I can put this in. 4 plus 3 minus 6 plus 4 times 66 minus 6 divided by 5. Great. As long as the operators are taking things that have the correct type, they'll produce the output that they should produce. So we could combine them. Like I've got arithmetic operators in there. I've got minus, I've got another minus. I've got these operators that take values, like numbers, and gives me back a Boolean. And I've got operators that take Booleans and give me back a Boolean. It all checks out. I want to be very clear, this is ridiculous. So if you're thinking, oh man, what, this weird thing I got to, no, that's just me showing you an example of how crazy we can get. Good computer scientists tend to go, oh, I can do this? What happens if I try this? Let's see if I can break it. If you do that, you're on a good track. So this is just that, okay. Less than, greater than, I already spoiled that. So now conditional execution. So now, when we ask a question that can be evaluated or true or false, we can add these conditions. We now can say, all right, well, here, let's go down here. I'm going to create a function. Def did fail. If grade is less than 50, return you failed. Actually, you know what? For simplicity, I'm going to add a print, even though we usually maybe not use a print here, but we'll see in a second. Does that make sense? I mean, even with the way the code is written, it's almost like English, right? Here's a function that takes a parameter grade. Presumably it's an integer, maybe it's a float. And I simply ask the question, is grade less than 50? If that question gets evaluated to true, the statement inside that if, that condition, gets executed. Only if that value is true, though. Only if the question I'm asking gets evaluated to true. Because 33 is, in fact, less than 50, right? Maybe someone got 99. What should we see printed out when I hit run? Were you right? Nothing should get printed out because grade took on the value 99. I asked the question, is grade 99 less than 50? Does that get evaluated to true or false? It's false. 99 is not less than 50. That's a false statement. So if we do if false, we don't execute that code. Just like with the function, you see that we have to have the colon. When we're defining a function, we need the colon. Well, if we're doing a condition, we can do that. By the way, we can have ands in here and ors in here. All that matters is that what this is must evaluate to a single Boolean. And if it's true, we execute the code. If it's false, we skip on over it. So maybe I should do this. I don't know. Oops. So, we only see blue. Why? Well, 99 is not greater than 50. We skip over the print fail, and then we go down and we write blah. What do you think is going to happen if we do this? I change it to 9. Take a second, think about it. Well, it executes the code inside the statement, and then it executes the code inside the if, and then it exits the if and carries on. I can have as many lines here as I want. I don't know. Oops. But again, that only gets executed if the condition evaluates to true. Any questions about this? Now, if I asked you to do this, write a function that divides a number by 2 only if that number is even, Well, now you have that if statement in your pocket. You can do it. The only thing you don't know is how to check if a number's even, but I'll show you that probably next on Friday. And of course, we could have, like I said, we could put everything we want in here. If grade is less than 90 and personality type is A, and desired career is med school, or your grade is less than 100 and personality type is AAA, then time to ask for extra credit. I can put whatever I want in there as long as it evaluates to a Boolean. What do you think happens if I do this? If I put the literal true in there? What does this mean for this function? Any ideas? Any thoughts about what I just did? Comments, concerns? What do you say?
Well, I'm just going out on a limb here. You took out its ability to actually know if it's true or false.
Nope. What do you say?
I completely already said, but I'm going to say it's always going to run because it's always going to be true because it said if true, do this, and there's nothing saying like to make it true or not.
Exactly. I threw the question away and I said, if true, if the thing there is true, if it's a statement that gets evaluated to true, and by the way, the statement true gets evaluated to true, then execute the code, meaning this function will always say fail, study more. I mean, that's pretty silly. Similarly, what would happen here? No matter what I do, those two lines of code, lines 4 and 5, will never run with the way this is written. Never. Because false is always false. And if the condition is false, the stuff inside the if never gets run. This right here is a very common pattern. If x is greater than 10, do this. If x is not greater than 10, do that. Seems reasonable, right? Maybe you've got two options. If condition is true, do that. If it's not true, do that. Because this is so common and computer scientists are exceptionally lazy, we created a shorthand for effectively this. No matter what this is, we can put an else there. Oop. Sounds like a helicopter. Pass. Fail. If true, otherwise that. So what does it mean? If grade is less than 50 and that evaluates to true, print fail. Otherwise, print pass. Cool. On Friday, I will go back up and cover a little bit more things, but I just want to give you a sense of all these different new tricks you have. What if you have a case where it's not this or that, but maybe this, that, or that, or that? Well, you can start to chain these conditions together. If year is less than 1960, print jazz. Else, if year is less than 1980, do that. Else, if year is less than 1990, and so on. That elif means like else if. And then at the end we have one last else. So we can use ifs, we can use elses, and we can use else ifs. Pretty handy. This is going to be critical. You're going to be using if statements a lot if you are a programmer. And you're going to be using them a lot for the rest of the semester. Make sure you understand them. And again, like I was saying before, this class is so accumulative. If you find yourself like, oh, I'm okay, but there's this and that that I'm not 100% sure on. Come to office hours. No one came this week so far. Come to office hours. Watch the videos. There's like 11 hours of like office hour type stuff you have access to. There's the videos. There's a lot of resources. So take care of it now. Don't wait till it's too late. All right, see you later.